All right, good morning, ladies and gentlemen. Um, so this is going to be a beast of a video, not necessarily too long of a video, but a lot of sort of intense problems. This was a difficult homework, and I'm referring to Calc Review 10. As you can see there, these problems were tough. So I'm going to go over the ones that were most frequently questioned and requested, and they are 5B and C, and then 6B and C. 6A and B. Actually, for 6, I think I go through all three. So anyway, let's start here. 5B. We want to find the x-coordinate of each point of inflection of the graph y equals g of x on the interval from -7 to 5, and explain your reasoning. So as we saw in yesterday's video, when we're trying to determine points of inflection, there has to be some sort of change in concavity. And there are two ways of identifying changes in concavity of the original function. So you can look at the derivative to see when it changes from increasing to decreasing, or you can look at the second derivative and see when it changes from positive to negative, or vice versa, of course, for both of those. So since I'm looking for inflection points of G, and I'm given a graph of G prime, to me it's natural just to simply look at when is the derivative changing from increasing to decreasing. So I would write something that says inflection points of G of x occur when G prime changes from increasing to decreasing, and vice versa. And as you can see on the graph here, here's a point where G prime goes from increasing to decreasing. And here's another point where G prime goes from increasing to decreasing. So, and I missed one, yeah, and x equals 2. So there are 3 points where G prime goes from increasing to decreasing, and then, so those are my 3 inflection points of G. Okay, so that one's pretty straightforward. Then we get this guy over here. So we're defined a new function h of x being related to g of x, but then there's also this extra term, -1/2 x squared. And we want to find the x-coordinate of each critical point of h on this interval. And then once we do that, we also have to classify these points as either relative max, mins, or neither on h of x. Okay, so first things first, when I hear critical point, I think derivative. So I want to take the derivative of h, and I want to set it equal to 0 and set it to be undefined. So the first things first, let's find the derivative. Well, h of x is g of x -1/2 x squared. Well, when I differentiate that, I get that h prime of x is equal to g prime of x minus x. So that's what I'm going to set equal to 0 right here. And I can rearrange this equation algebraically to say that g prime of x is equal to x. And as you might notice, this is the graph of g prime. So this equation, g prime of x equal to x, is the same thing as saying, where is y equal to x on this curve? Where is y equal to x on this curve? Well, there's one point that jumps out right at us, and that's where the point when x equals 3, you can see that y equals 3. But if I draw the line y equals x and connect 0, 0 to 3, 3, you'll notice that there's actually a second point here on the graph of g prime where y equals x. And so I have to actually identify that point as well. So what I'm going to need to do is determine the equation of this part of the curve and set it equal to x and solve. Well, this is a circle, the top half of a circle, centered at the origin with a radius of 2. So the equation of that part of the graph is over here. Well, the equation of that part of the graph in particular, I'll just write that equation separately, is g prime of x is equal to radical 4 minus x squared. So on that portion of curve, on just this interval here, g prime of x is equal to the equation of that semicircle. All right. Now, using the equation that we're trying to solve, which is, well, where does y equal x, or where does g prime equal x? I'm going to take the value of g prime on this interval, and I'm going to set it equal to x. So I have this equation here that I'm trying to solve. Going forward, I end up that x is equal to radical 2. Yes, technically, x equals negative radical 2 also would be a solution to this equation. But if we look up at the curve that we're dealing with, if I were to extend the y equals x line, for our purposes, the graph that we're actually working with, x equals negative radical 2 is not actually a solution. So I did not include that in my solution set. So my only other critical point is x equals radical 2. As you can see here, h prime of x equals 0 at x equals radical 2 and x equals 3. Now, I didn't mention this, but we do also have to check to see if h prime can be undefined. And on this interval, h prime of x is not going to be undefined because, as you can see, first of all, g prime is continuous, right? There's a value of g prime for all points along the interval. So g prime of x can never be undefined on this interval, and, well, neither can x be undefined on this interval. And so h prime of x, as a result, can't be undefined. So we only have these two critical points, x equals radical 2 and x equals 3. Now, to determine if they're local max or min or neither, we need to use the first derivative test. And so what I like to do is set up a number line. Of course, my x end point is -7 and 5. I basically place my critical points on this number line, and then I just go ahead and choose a value to the left and right of each critical point and evaluate the derivative at these points to the left and right. So starting with radical 2, I chose x equals 0. And so I evaluated the derivative at 0. And really all I'm looking for is what's the sign of the derivative, meaning positive or negative. And so in order to determine this, I need to find, well, g prime of 0 minus 0, right? Because remember, we determined before that h prime of x is equal to g prime of x minus x. That's the equation we're working with. So g prime of 0 minus 0, if you go back and look at the graph, g prime of 0 is up here. It's 2. 2 minus 0 is 2. And so really all I care about is that h prime of 0 is positive. And so I've identified that here, that the derivative is positive when we are on the left of radical 2. I choose a value now to the right of radical 2, but also to the left of 3. I chose 2. H prime of 2 is going to be negative, and I'll show you why. So I need to check out g prime of 2. G prime of 2, as you can see here, is 0. And of course, 0 minus 2 is -2. So overall negative, and that's what I care about really. All right, and now I have to move on and choose a value between 3 and 5. I chose 4.5. And if you go look at the graph of g of 4.5, if you go look at the graph of g prime, I should say, g prime of 4.5 is this number over here that's crossing the x-axis. So that was just an easy point that I decided to choose. And you'll notice that actually I filled out the areas. It turned out I didn't need them. I just did that ahead of time. So just ignore those areas. But anyway, G prime of 4.5 is 0. 0 minus 4.5. G prime of 4.5 is 0, 0, and then I would, of course, subtract 4.5 because that's the equation of H prime. And that, of course, overall is negative, which is all I care about. And there we have it. So now we have the evidence to make our claim. So we can say that there is a local maximum at x equals radical 2 because H prime changes from positive to negative at that point. And for x equals 3, there's neither a local max nor a local min. And that is because there's no change. There's no change in the sign of H prime at this point. All right, there we have it. That's B and C. If there are any further questions about any of the details, please let me know. All right, let's move on to this guy. This guy looked innocent enough. I mean, you have a triangle, really easy to find area under the curve, but lurking underneath this simple exterior was, a pretty tough problem. I gotta admit. So I'm only gonna do, actually I think I go through A, B, and C. So anyway, let's start with A. So we wanna find this integral and of course show the computations. Well, we are told that f of x is equal to g of x minus cosine of x over 2. So I just rewrote that here. And then I applied the integral that we're trying to find. So if we're integrating f of x dx, that's equivalent to saying that we're integrating g of x dx minus the integral of cosine of x over 2 dx. All right. The left side is easy enough. This piece here is easy enough because that's simply, well, since this is the graph of g, then the integral from negative 2 pi to 4 pi of g of x dx is just the area under this curve. And the area of like sort of this left triangle is 2 pi squared. The area of this right triangle is 4 pi squared. And I admit my first run through here, I wrote the areas as just 2 and 4 because it didn't process to me that these units are actually like 1 pi each. So this base here is actually 2 pi and the height is 2 pi. So when we find the area, we do 1/2 times 2 pi times 2 pi, which ends up being 2 pi squared. Similar for the other triangle. So very, very tricky there. That's one like curveball that they threw at that would have tricked me. So anyway, when you put those two areas together, you get 6 pi squared. So that first integral, pretty straightforward. The second integral here, kind of tough. You need to find the antiderivative and then evaluate that at the upper bound and the lower bound, and of course subtract those two terms. So you might be able to just think through the antiderivative on your own without doing u sub. I just did u sub just in case for those of you that are just completely unsure how to approach this antiderivative. Look, in general, folks, if there's an antiderivative that you're not sure how to do, then either you have to use your calculator or it's a u sub problem. In AB calculus, it's either a very simple integral or it's a u sub if you're expected to do it by hand. And so in this case, this is a u sub problem. I set u equal to x over 2. That means du is equal to 1/2 dx. Equivalently, 2 du is equal to dx. So I take my original integral and I just kind of replace pieces. Instead of dx, I write 2 du. And instead of x over 2, I write u. So now this becomes 2 times the integral of cosine of u du, which is a lot simpler. The antiderivative of cosine is just sine, right? Another way of saying that is the derivative of sine is cosine. So this antiderivative ends up being 2 sine of u plus c, and then I actually replace u with x over 2. Now, so this is my antiderivative, and I'm going to evaluate that at the limits of integration. Okay, so notice that I did go back to my x variable, which means I don't have to change my limits of integration. If I tried to just stick with the u variable, I would have to change the limits of integration to be with respect to u. I didn't do that here, so I'm going to use my original limits of integration. So I now write the antiderivative. And this is the notation. So you say, I'm going to take this expression and evaluate it at 4 pi and negative 2 pi. Notice I omitted the plus c, but that's just because that constant would cancel because we're going to be subtracting these two terms. So I just ignored the constant. All right, so anyway, I have 6 pi squared. That just kind of comes along from above. And then I have 2 times sine of 2 pi. You might be wondering where the 2 pi comes from. Well, 4 pi over 2 is 2 pi. Minus 2 sine of negative pi. You might be wondering where negative pi comes from. Well, negative 2 pi over 2 is negative pi. All right, so now again, just kind of simplifying further. Sine of 2 pi is 0. Sine of negative pi, also 0. So 6 pi squared minus 2 times 0 plus 2 times 0 is 6 pi squared. All right, so that is part A. That's only part A. A lot of work for part A. All right, part B. Find all x values on this interval for which f has a critical point. All right, so here we go, critical point. Once again, critical point means I take the derivative of the function and set it equal to 0 or undefined. All right, so now my next job is to determine f prime of x. Well, based on the definition of f, which is g of x minus cosine of x over 2, that means f prime is equal to g prime of x minus, plus 1/2 sine x over 2. This piece here, the 1/2 sine x over 2, that's the chain rule, of course. The derivative of cosine of x over 2 is negative sine x over 2 times 1/2. So it's the derivative of the outer evaluated at the inner times the derivative of the inner. All right, now, of course, critical value, I have to set f prime of x equal to 0. And so if I set this guy equal to 0, algebraically, actually I see I made a little bit of a mistake. Algebraically, this should be negative, g prime of x is equal to negative 1/2 sine of x over 2. Let me pause real quick. All right, we're back. I just had to adjust a few things. But of course, setting this equation, setting f prime of x equal to 0, is equivalent to saying g prime of x is equal to negative 1/2 sine of x over 2. Now, the tricky thing is g prime of x, that's the graph of, that's the derivative of this graph here. So, and notice that the derivative changes for different intervals. So what I first have to do is focus on this interval here. And on that interval from negative 2 pi to 0, g prime is equal to 1, right? We're referring to the slope of g. And on this interval, the slope of g is 1. So I'm going to go back down here. And from negative 2 to pi, as we just saw, g prime of x is equal to 1. So where I wrote g prime of x is equal to negative 1/2 sine of x over 2, I'm going to rewrite that as 1 is equal to -1/2 sine x over 2. And using your calculator, you can see that there's no solution for this equation on this interval. All right, so there's no critical point. Well, there's no way that f prime of x could equal 0 on the interval from -2 pi to 0. But of course, we have a second interval that we need to focus on, and that's from 0 to 4 pi. And from 0 to 4 pi, g prime is equal to the slope of this line right here. So the slope of that line ends up being -1/2. So g prime of x is -1/2 on that interval. And I'm just going to do the same thing as before. I'm going to set -1/2 equal to -1/2 sine of x over 2. And so basically, this comes down to the question, well, when is sine of x over 2 equal to 1? Well, sine of pi over 2 equals 1. So that means sine of x over 2 equals 1 when x equals pi. Right? Because if sine of x over 2 is 1, then we have -1/2 equals -1/2. So anyway, this equation is solved when x equals pi on this interval. So that is one critical point, x equals pi. Now, we can't forget that critical points also occur when the derivative is undefined. So to set f prime of x equal to be undefined, this is supposed to be x over 2. To set f prime to be undefined, we need to see, well, is there ever a situation where g prime is undefined? Or is there a situation where 1/2 sine of x over 2 is undefined? Well, 1/2 sine x over 2 is a continuous function, and therefore that portion of f prime will never be undefined. But is there a portion such that g prime does not exist? Well, if we look at the graph of g, let me erase everything here. If we look at the graph of g, which is this guy right here, you'll notice that there is this corner here. And as you know, if a graph of a function has a corner, then the derivative does not exist at that point. All right, so since g prime is undefined at x equals 0, that means f prime is undefined at x equals 0. All right, so, and I basically just kind of explained that here. Since there's a corner on g of x at x equals 0, this means that x equals 0 is a critical point because g prime of x doesn't exist. And of course, f prime of x is related to g prime of x. So if g prime is undefined, then that means f prime is undefined. Okay, so there you have it. So you have two critical points. They are at x equals pi and at x equals 0. All right, part C. Part C actually was probably the easiest part of this problem, which is odd. Usually part C is the most difficult, but at least in my opinion. So they define a new function h of x, and we're asked to find h prime of -pi over 3. Well, h of x is the integral from 0 to 3x of g of t dt. This is a direct application of fundamental theorem of calculus part 2. So just explicitly writing out the definition that they gave us for h of x, again, it's the integral. But fundamental theorem of calculus part 1 says that a definite integral is evaluated by finding the antiderivative evaluated at the upper bound minus the antiderivative evaluated at the lower bound. Okay, So really, we can say that h of x is equal to big G of 3x minus big G of 0. So then when I want to differentiate h to get h prime of x, I just differentiate this side right here, both of these guys. Well, the derivative of g, big G of 3 of x, is just little g of 3 of x times 3. That's the chain rule. The derivative of big G of 0 is 0 because big G of 0 is a constant. All right, so we actually get this nice equation. And now I want to evaluate that at negative pi over 3. So that's equivalent to just 3 times G of negative pi. And going up here to my graph of G of negative pi is this point right here. This is the point negative pi, comma, pi. And that is the value of interest. So that is the value, the y coordinate here is G of negative pi. And so G of negative pi is just pi, and that's your final answer, 3 times pi. All right, folks, so hopefully this was useful. Tough problems for sure, but if there are any other questions, let me know. I think I'm gonna post another assignment dealing with these types of problems because I really have some sort of feeling that you'll see something like this on the upcoming AP exam. So I want to give you as much practice as possible. All right, ladies and gentlemen, hope all is well. Take care.